All right, welcome back everybody. Today we're going to be building more microservices in Go. We're going to build out a very basic, very simple API in Go using Postgres. We're going to deploy it with Docker onto Heroku. We're going to make use of the free Heroku Postgres add-on so that we can just get a feel for how to deploy really basic microservices on Heroku and get things up and running. Um, this service, you'll be able to use it if you have like a front-end app built out in React or Angular. Maybe another microservice can call this, or you can just manually call it with Postman or curl. The API we're going to be building out is going to be really straightforward. We're going to just build a simple API that allows you to do CRUD operations on homes. So that's create, read, update, and delete on homes. So maybe you have some kind of real estate business and you want to track the homes that you're purchasing or your agents are selling. So that's what we're going to cover. We'll also go over how to run migrations, right? So anytime you have a database or a data store, you need to be able to set it up and you need to be able to maybe alter tables, create new tables, and just kind of have rules for the database. So we'll cover that as well. Libraries we'll be using, we already covered the Heroku add-on specifically for Postgres, totally free to use there. For our API, we're going to be using Chi. It's just a lightweight router. I'm a big fan of it. There's other ones out there. I believe Gorilla Mux, or you can just use the classic Go HTTP standard library. Works just as well. For our Postgres client and kind of semi-lightweight ORM, we're going to use Go PG. This is a very well-maintained repository, very well-maintained package and library. So big fan of that. And for handling our migrations, we're going to use GoPG/migrations. This is also very well maintained, and it comes from similar people as GoPG. So these are two that work very well hand in hand together. Okay, so we've covered this. Let's talk a little bit about the basic setup for our repository that we're going to be using. Um, I'm a big fan of Katzine's structure for Go apps. She has a great talk given back in GopherCon about how to structure your Go apps. I'm going to link this in the description. Check it out. Listen to this on 1.5 or 2x playback speed. Really good structure, really straightforward for organizing microservices in Golang. So that's how we're going to structure it. Let's hop into the code here. I have set up a basic just empty project here, empty project in Goland, and let's walk through. So we're going to start by creating our Docker file, our main.go, and just kind of the package structure. Okay, let's hop into that. So the first thing we'll do is just create the folder layout here. So let's create some directories. We're going to do cmd. We're going to do we'll call it server, and let's create our main.go. What does it say? Looks like a file name. Yes, create file. Okay, cool. So package main and func main. Let's just do a log.print. And we'll just say we're up and running. All right, so there's our CMD server. So CMD is going to hold all of the executables we're going to build basically when we compile. When we compile this, there will get a generated executable in this folder, and that's what CMD holds, right? It's all the commands we can run. Let's make a second directory here. We're going to call it pkg, that's package. And this is going to hold all of our modules essentially. So we'll create one of them, we'll just call it API. We'll create a second one, and we will call this, what should we call this? DB. And let's hope there's no conflicts in these names. So in the API here, we'll just do api.go, package API, good. And in here, we're just going to do our db.go. Okay, so API is going to hold all of our routes, essentially. It'll hold our setup function to create our new router. So maybe something like func new API. And this will probably return like a Chi router eventually. For the time being, it's just blank. And database, we already have that file. This will hold all of our basically data layer, data store operations. So anything that actually interacts with the database here. So maybe we would have a func like new DB, and this will return like our actual, this will connect to Postgres, make sure that's all running. Maybe this will run migrations. Maybe we'll have a separate function to do that. We will get into this shortly. Okay, so we have our packages set up. We have our buildable kind of CMD set up here as well. So now let's set up our Docker file and our Docker compose.yaml so that we can run this locally here. For the YAML, I'm just going to use version 3.3. You can use whatever you'd like. And services, we're going to have our API. We're going to have our API service. And we'll figure out the context for that in a bit. We'll have our API service, and then our other service is going to be our database service here. So in here, we can just pass in any basic Postgres image. So we can look up Docker Postgres image here, and let's just take the official Postgres image, right? And let's find, here we go. And we will just paste that in. What do we need here? So image, there we go. Let's get rid of this line. Okay, Postgres password, sure. We'll say admin. I believe there's the user as well. Let's see, Postgres password. So user is an optional environment variable. If not specified, the default user of Postgres will be used. So let's get rid of the user here. And let's see, this is required. It must not be empty or undefined. Okay, so I'm fine with that being admin. All right, so we're good to go. Oh, we gotta indent these. Okay, so let's work on our Docker file now to actually build our main.go and get that running. And from there, we can wire that up into our Docker compose. So let's get started in here. Let's import from golang. So from golang, I'm not going to specify a version or anything. We'll just take the latest. Let's run make dir. So we're going to make a directory. We are going to add everything into that directory. We're going to set that to be our working directory. And next, we're just going to build that. So we're going to run this command here, run, go build. We're going to output main, and we are going to pass in cmd/server/main.go. Finally, we're going to expose this thing on 8080, and we're going to run the command app/main, and that will be the executable that we built. Okay. Docker compose here. So we're building from this, when you pass in this dot, it looks for the nearest Docker file, essentially right here in the same directory. So that's what we're building from. Let's expose that port. Ports, what do we do? 8080. So there's the internal to external mapping. That's good there. So we'll have to wire up a connection between API and database so that we have those in our environment variables here. Let's see. Environment, we're going to put one in that's port. When you deploy on Heroku, you always need to use this port environment variable. They choose the port that you listen on, so you need to listen to that. So this is 8080 that we're using locally, and let's see. Yep, that should be all the environment variables we need. Let's try to build this. So we'll do Docker compose up and pass build. Okay, so we're up and running here. We see our database container, Postgres has started up, and we see we get our nice little log. We are up and running, and then because we just don't have anything else in main, we just terminate and API exits. Cool, so let's close this down, Docker compose down. All right, let's link the two. We can use the depends on, and we can use DB. And as well, so this controls the startup and shutdown order. So our API can't really function without this database. So we need to make sure that database starts up first. And that's what depends on does. Depends on DB. And later on, we might run into this issue where even though the database, so depends on basically ensures that this container, this database container has started. That doesn't mean the actual Postgres service has gotten up and running. You can kind of see in these logs, there's a lot that happens. There's a lot that happens before, so we start up the database container, and then there's a lot that happens before it's actually ready, ready for connections, right? So database system is ready to accept connections. During that time, API would have already started up and probably started to try to connect to DB. So we might run into this issue where we're going to try to connect and the database isn't ready. So Docker has this little workaround here. You can run this command and basically wait for it. And so you can put in a custom kind of a script that'll just ping the database and kind of figure out, is it awake? Is it ready for connections yet? So we'll handle that later. We won't worry about that for now. Okay, we got a basic service. We have our Docker file. We have our Docker compose file. So we're good to go. Let's start setting up our Chi router next. So let's hop in over here and let's just look at their example. So here's just the basic example. Let's just bring all of that over and we'll bring it in. First thing we're going to need to do is go get Chi. So let's paste that in. Cool. And we see now it's in our Go mod. Okay, so now all these imports are resolved. Okay, so things we need here. So we're creating a new router. We're going to use their built-in logger middleware. This just logs any incoming requests. It's just a quality of life thing to show you when your API actually gets hit. And they're setting up just a basic endpoint on just slash that just writes back welcome to the user. And they're listening and serving on port 3000. Okay, so let's move this over to our API and new API. So in here is where we should set up our router. So set up router, okay? So let's bring this over here. Okay, there we go. So this is going to create the new router. This is going to use middleware. This will set up any endpoints. That's fine for now. We'll have individual handlers below. And then let's not listen and serve yet. Let's have this return that router. So what does this return? It just returns a chi.mux, it looks like, chi.mux. Okay, and let's return R. All right, so there we go. And now in main, let's create that router. So let's say router is API.new API. Okay, and now we can listen to that. All right, and let's get our port. Remember, we have our port set here in our environment variable. So let's get that os.getinv and port. And we can listen and serve on that instead. So let's just do a format.sprintf there. And it's a string and it's port. Okay, this returns an error, so we can handle that. And we'll just do a print line. Error, error from router. We'll just say that. We can do a printf. And we can format in the error, and let's give a new line at the end. Okay. Okay, so we're creating our little API here. We're building up our new router. We're going to log out that we're up and running. We're listening on the port, and we're handling any errors here. All right, so let's build this again. Okay, so we're up and running. I'm going to split this. And now we should be able to curl localhost 8080/. And let's do a GQ. Okay, so we get a log line back here. and we returned 200. There's no JSON to parse, so JQ isn't helpful here. We can do verbose, and we see that we got a 200 back. All right, so we're up and running. We have our basic API, our basic router running. So remember, we were going to cover homes, right? So we're going to cover CRUD operations on homes. So we should create a handler for our homes endpoint here. So let's hop into the Chi documentation and we can find what we're looking for. All right, so we are right here, and you can have sub routers in there, right? So you make your initial router, and then you can say r.route/articles, and you pass in a new router here. You pass in this function here that takes in the router, and you handle these endpoints on top of it. So we'll do that similar thing for homes. So we can copy this over here. And let's see. So we have our middleware. Let's paste this in. We don't care about pagination. We just want to handle some of these basic Git endpoints for now. Okay, so Git. So what we'll do some function Git homes. Let's get rid of this white space here. So func Git homes. What will this take? Let's see. I believe it's a response writer and a request. Yeah. Okay, let's just leave that blank. So there's Git homes. We'll do one for create homes, update home, and homes. Okay. So there's Git. We'll do post. We'll say create home. Create home. Get homes. Update home. And then finally delete home. Okay. Create. I'm just gonna reorganize that. Put and finally delete. Okay, so we have /homes and we have our handler for git, put, etc. So let's put these in. We're just going to put a basic response in each of these for now. All right, and we don't need this. Sure, we can keep this. We can keep this base handler. All right, so let's get rid of that comment. Okay, so here's all of our handlers. That looks good. Let's restart this. Okay, and let's test those new endpoints. So let's test the base endpoint here. We get hello world. That looks good. We can test /homes, and that's get home, and we should be able to do x post create home and put update home, and then finally delete home. Cool. So now we have all of our handlers here. So we have get homes. One additional one I'm going to do here. So for update home, you need to pass in a specific home. So let's add in a URL parameter here. So let's look in the documentation and we can find this here. And right here, we can see in the subrouter section, you can put in, what do they call it? URL parameters here. You can put in URL parameters into your request. So for update home, let's go ahead and put in this here, home ID. And we can do one more endpoint. Why not? We can do get home by ID, and we can put in home ID. And let's create that function. Get home by ID. Get all homes. Cool. So there we have that. Let's test these out really quickly. Let's see. So you can get it, the URL parameters, just like this. Let's do that, and let's write those back. So get home by ID. Let's get the actual home ID, and that's the key, home ID. And we can write this back now. We'll change all this later. Don't worry. We'll put JSON responses into all of these. Get home, and we'll do the ID. We'll give it home ID. Okay. And similarly, let's do this for update. And I realized as well, we'll want to do this in delete also because you'll need to delete a specific home. This will be update. Okay, so let's do this similar pattern for delete. Cool. And let's change that name too to more accurately reflect that by ID. Let's do that as well. Okay. All right. And cool. Let's test that one more time. All right, we're up and running, and let's rerun this here. So we see delete, and we don't see any parameters. So let's see, delete/test. There we go. So that one passed through. So there was a 405 there. So that requires, when you just pass delete without this home ID URL parameter, it's going to give you a 405 because you don't have that URL parameter. So that's fine. We're on board with that. We're okay with getting a 405 back there. That's kind of like a nice built-in validation for us. It ensures any request that comes to this handler here will have that home ID. Similarly, we can do a get request, get. There we go. And we see 200 back and get test. Awesome. So there's all of our handlers set up. That's good. For our next step, let's start thinking about modeling our data structure for home.